We're going to do module 29 today. The title of this module is Biology, Cognition, and Learning. So we're going to talk about how kind of all of those relate to one another. Okay, so first thing I want you to do is to write in your notes about a food aversion you have learned and how you learn that aversion. And I want you to think about how biology and cognition played a role in learning your aversion. I just noticed I have a typo. So take a minute to write that down in your notes. Okay, so we're going to be talking about the biological constraints on classical conditioning. So basically, animals are limited by their biology to an extent. And how much and what we can condition them with depends on the animal, really. And so what we have found is that each species has predispositions that allow it, excuse me, that allow it to learn associations that are going to enhance its survival, okay? And so this is called preparedness, basically. Preparedness refers to the, limitations that each species has that will allow it to learn some associations easier than others. So this guy, John Garcia, he studied how some associations can be made readily by animals and others not so much. So, for example, he found that rats developed associations with tastes and sickness, but not sounds and sights. So, for example, he did not find that sounds or sights could elicit a sickness response as well as taste could. So, he found that humans, like rats, usually develop aversions to taste of things that made them sick, not the sounds and sights of it. So that demonstrates preparedness because basically those animals were prepared to learn that association because that makes sense with their biology as it does with ours, but they were not able to make the connection between, a light and getting sick, because those two things don't really relate to each other naturally. So there's a limit, basically. So learned associations are adaptive. Some learned associations are particularly adapted, like nausea, pain, and anxiety. And our preparedness to associate a conditioned stimulus with an unconditioned stimulus is adaptive. So basically, evolution has allowed us to learn some associations more than others because that helped our ancestors survive. So if they had that trait, they were more likely to survive and pass on that trait to future generations. Now, something else animals are known to have is called a sensitive period. And this is where animals and humans are able to learn more readily than at other times. So in humans, this is really easy to see with language. If you started learning 2 languages from a young age, you're probably better of a bilingual speaker than people who, mastered 1 language as a child and didn't try to start another language until they were an adult. And that's because we have a sensitive period for language. And if you don't learn language before this cutoff period, it's very hard to be fluent in a language. And we'll talk more about that later. But that's called a sensitive period. Okay, so that was kind of the biological constraints on classical conditioning. Now we're going to talk about the biological constraints on operant conditioning. So again, we most easily learn and retain behaviors that reflect our biological predispositions. So when you are pairing a reinforcer with a behavior, like if you want, an animal to do something, you need to use a reinforcer that makes sense. So for example, you could teach a pigeon to peck to get food and flap wings to avoid a shock, because this kind of follows their biology, right? Naturally, they're pecking to get food, and naturally, they're flapping wings to avoid, aversive stimuli. Now, if you tried to teach a pigeon to flap their wings to get food and to peck to avoid a shock, it would be very hard to teach that animal to do that. So you have to kind of work with a species biology, including humans. Now, there is this thing that can happen. It's called instinctive drift. So let's say you do teach a animal, a pigeon, let's say, to flap wings to get food, which would be hard to do in the first place, but let's say you did. Instinctive drift can occur where basically the learned behavior will, it kind of goes along with extinction, but it will kind of stop doing that behavior and go back to what naturally it would do. So instead of flapping of wings to get food, it would start pecking to get food. And so that's an example of instinctive drift. Okay, now let's talk about cognition's influence on classical conditioning. So there was this guy that was named Robert Rescorla. He was a behaviorist, and he found that animals could determine the predictability of an event. So Robert Rescorla would shock these rats. He would give them a shock after they were shown a light and a tone, okay? So they would be shown a light and then a tone, and then they would they would get shocked. Now, what he found was that rats only were responding with fear to the tone and not the light, because they had reasoned basically that it was more likely that they would be shocked with the tone and not the light. And so this shows some cognition that's happening on the side of the rat, that they have now figured out, and they've thought about this, that the tone is going to get me shocked. The light probably isn't. So they don't respond with fear. We also have found cognition's influence with humans, so with classical conditioning. So what they have found is that when British kids, in a study, British kids were given ice cream or Brussels sprouts when watching cartoons of things they didn't know. So cartoons of random shows that they had never seen. And what they found is that they liked the characters more when they were the kids eating ice cream. Okay, so like let's say there's two groups of kids. Half of the kids are watching a show they've never seen before and are eating ice cream. And half of the kids in the other group are eating Brussels sprouts while watching the same show. What they found is that the kids like the show more when they're eating ice cream. And so basically, this shows that conditioned likes and dislikes are even stronger when people are aware of them. Like, they know they're eating ice cream, right? They know that that makes them happy. But even because they know that, it actually made the association with a positive experience with that show even stronger than if it was unconscious. So cognition does matter. Now, this is quite against what a radical behaviorist would say. A radical behaviorist would say the only thing that matters is behavior. But modern research shows that the thinking that's taking place beyond just the behaviors do matter. So that would be more cognition. Okay, so now let's talk about how cognition and operant conditioning relate to each other. So one interesting thing that people have found is that animals on a fixed interval schedule will start performing the responses closer towards the interval, which demonstrates an expectation. Perfect example of this is when it's about to, when you're in a classroom and the bell is about to ring in a few minutes, what do kids start doing a few minutes before the bell rings? They start packing up because they are expecting it's time to go. And that's on a fixed interval schedule. It happens at a fixed time each day. So they know that that's the time to respond. Animals do this as well. Another interesting thing is that rats studied by this guy, Edward Tolman, were shown to display the creation of a cognitive map. So a cognitive map is a mental representation of the layout of one's environment. Basically, you could, and I'm going to ask you in your notes to do this, I want you to draw a cognitive map of your house, basically how you would navigate maybe from your room to the kitchen. And you have a cognitive map of that. You would go, maybe straight and then right, and then you make a left. That would be your cognitive map. Now, interestingly though, this map for the rats was not demonstrated until there was food placed in the maze, which caused the rats to use the fastest route to get the food. And these rats had not been reinforced with food before. They had just been allowed to kind of wander the maze. But when when there was a reinforcer present, they suddenly showed that they had all this learning, this cognitive map. So this is what we call latent learning, and it's called that because it occurs, but we don't know that it has occurred until there is an incentive to demonstrate it. So, maybe in humans, sometimes this can happen when, a kid has learned a certain skill, but they don't demonstrate it until there is a reward at hand. And then something that also has been demonstrated is this term called insight, where a person has a sudden realization of a problem solution. And that's different with like trying out a bunch of different solutions. So that also applies to operant conditioning because it kind of shows cognition. Your brain, what's happening, the thoughts basically, the whole point of the cognition and conditioning is that your thoughts do matter with how you behave. That's the point. And so there is an element of cognition. Okay, now I want you in your textbook, well, actually in the PDF I've uploaded onto Google Classroom, I want you to look this up. I want you to define intrinsic motivation and extrinsic motivation. So you're going to pause the video. I also want you to tell me what a problem can be with giving rewards. We call this the overjustification effect, and tell me what studies demonstrate this. And then in your notes, I want you to tell me what problem-focused coping is and emotion-focused coping. And you can only use words and examples a first grader would understand. Okay? So do that. Pause and do that, and then add that to your notes, and then we'll proceed. Okay. So perceived loss of control. Okay? Now, learning influences our sense of empowerment or helplessness. When we learn something and we feel that we were able to do it successfully, that is a very empowering thing. If we learned that we try something over and over and over again and we're constantly failing, this is not a good feeling, and we would call this helplessness. So this researcher, his name is Martin Seligman, his associates, they did a study where they found that if a human or an animal experiences several negative events outside of our control, they can experience what we call learned helplessness, okay? So basically what he did in this study is he put these dogs in a box and they could not escape at all. And inside the box, I believe he would shock them, and they could not escape. And long story short, the dogs learned that there was no escape, and so even when the cage was opened, they wouldn't leave because they had learned that there was no way out. And so that is what we call learned helplessness. We'll watch this video at a later time. Now, oops, that's not what I wanted to do. Okay, back here. So what they find is that perceived loss of control can hurt your health as well because it causes anxiety. And control can explain the link between economic status and longevity. So richer people tend to have more control over their lives, which could explain why richer people tend to live longer lives than poorer people. In addition, obviously, to, access to healthcare and all of that, but that is a level of control that they have that low socioeconomic people don't always have. So us feeling in control is very, very important to our basic human functioning. And we'll talk more about this together in class. Oops. Okay. So sometimes though, when we have too much choice, that can also be damaging. They call this the tyranny of choice, where we have so many options, and this can cause us to feel regret over some of the things we left behind. So maybe you're trying to find a new pair of boots, let's say. I just thought of this because I'm looking for boots, and there's so many options, and you choose one, and then you go home and you're like, shoot, I kind of wish I got the other ones. That's kind of an example of tyranny of choice, because there's so many options that it's hard to weigh them all. So I want you to think of some examples how tyranny of choice is applied in your life. And again, this is all kind of showing how, our thinking plays a role in our decisions. Okay, now, perceived control. So it's very important, basically, for good, proper human functioning to, well, this is the ideal, I guess we should say, is to feel like we're in control. We're in control of our lives. We're in control of our, fate. We're in control of our situation. And this is what we would call an internal locus of control. Locus referring to the location, okay? Internal locus of control. This is what we want. I feel in control of my life, in control of my success, all of that. Other people, if you don't have this and you feel that things are out of your own control, we would call this an external locus of control. And this is the idea that there are forces beyond our personal control that determine our fate. And so what they have found is that people who have internal loci of control, these people do better in school, work, health, and happiness over time. If you think you are in control of your situation, you tend to be a happier, healthier person. If you think the world is controlling you and you are out of control, it doesn't have usually great outcomes. They tend to be more stressed, more anxious, probably don't take action because they think that it's not going to do anything because they're out of control. So, compared with their parents' generation, many young Americans now express an external locus of control. So, young people like you and I tend to think of our lives being operated more by others than ourselves. What do you guys think about that? Okay. Now, different but related is self-control. So when we have a sense of personal control over our lives, when we have this sense, an internal locus, we are more likely to develop self-control, which is the ability to control impulses and delay short-term gratification for greater long-term rewards. So, putting off going out and partying every weekend so you can get into a good college would be an example of self-control. And what they have found is that self-control has been linked to good health, higher income, and school performance. And in cross-cultural studies of children, self-control outdid intelligence test scores in predicting future academic and life success. So even intelligence isn't everything. How you conduct yourself is very important for later outcomes. And self-control can be taught, but it does require a lot of attention and energy. And it requires an internal shift of mind that I am in control of my life, I am in control of my body and my health and my happiness. And then once you have that internal locus of control, then you can start mastering self-control. Okay, and that's where we're going to stop for today. I hope you took good notes. If not, go back, rewatch it, pause it, and I will see you guys later. Bye.